Okay, chapter 3, section 1, we're going to be solving systems of equations graphically. So this is the first part of section 1. Tomorrow we'll do the second part, which will be solving systems in a different way. But today we're just focusing on graphing them. So a system of equations is two or more equations with the same variables. So here we have two equations. They both have x and y. So this is called a system of equations. To solve a system of equations with two variables, we have to find the ordered pair that satisfies all the equations. So today we're solving by graphing. Our answer, so we're trying to find an x equals and y equals, a number for x and a number for y, that both satisfy these two equations here. We can easily see what x is going to be equal to and y is equal to when we graph our two equations by where this graph intersects. So this graph where the two lines intersect, that's our answer to this system of equations. Yeah. So this point where it intersects, what point is that? It says it there. -2, -3. So what's our x equal to? So remember, x is the first one, so x is equal to -2. What's our y? -3. So we could plug -2 into our equation for x and -3 into our equation for y, and we'd be able to solve both of them. So we're just focusing on where our two lines of our graphs intersect, and that's our answer. We have three different types of equations here. So if we have, remember, we have two equations. So we're going to have two equations. We can have one solution to our two equations, which will be the point where they intersect. We can have infinitely many solutions if our two lines are the same exact line. So here we have a line here and another line that's right on top of it. It's the same line. So this would give us infinitely many solutions because they touch in infinitely many places. And then if our two lines are parallel, do parallel lines ever touch? No. So we would have no solution if our two lines are parallel. Okay, so here we are solving the systems of equations. I'm going to be super nice. I know that you guys know how to graph this because we did that in the last section. You guys also did this in Algebra 2. So for the graphing questions, we're going to plug them into, I don't know if you guys have heard of Desmos, the graphing thing. So if you go, and now I can see where x is equal to a number and y is equal to a number. So we're looking at the point where these two graphs intersect. We're looking at this point. So what would this point be? What's the coordinate of this point? 2, -4. So we go to the right 2, down -4. So our point's at 2, -4. So what's x going to be equal to? And what's y equal to? -4. So if you guys want to graph them by hand, you're more than welcome to. If you want to graph them using something that'll graph it for you, you can go ahead and do that too. The important part here is that you see where they intersect, and that is your answer. That's it. We're going to go to Desmos and have it graph it for us. So where do our two graphs intersect here? Where do our two lines intersect? They intersect right here, which would be 3, -1. Perfect. So what's x equal to? And what's y equal to? Awesome. All right, let's do the next one. So again, we're going to do the same thing. We're going to put it into our graphing. Perfect. They intersect. They go to the left 2, so this would be -2, and down 3, so -3. So what's our x equal to? And what's our y equal to? Awesome. I'll leave these two up here for a second if you want to copy down the graphs. What point do they intersect at?
-1 and -15.
-1, -15. Awesome. So what's our x? And then what's our y? Perfect. All right, so that's it for the notes. What would our answer be if the two lines did not intersect? No solution. What if the two lines were the same exact line? What would our answer be? Infinitely many solutions. Yeah.